Lewis structures for organic molecules. Now, what I'm about to do is something that you're not going to do in the class. I'm rarely, if ever, going to provide a formula and ask you to generate a good Lewis structure for it. Having said that, you are going to be working with line angle structures where they're already drawn out for you, and you need to kind of understand how to work with it. It's also useful to be able to go from a Lewis structure to a molecular formula and to take a molecular formula and go to a Lewis structure. So while we're establishing those skills in the first couple of weeks of the class, it is a valuable exercise to review your Lewis structure skills in the context of organic molecules. This is acetic acid, this is acetone, and what would you do if you needed to generate a Lewis structure here? Well, you would need to identify what the central atom is, and of course, carbon is always the central atom in organic chemistry. Organic chemistry is all about carbon, fundamentally. That's what makes it organic chemistry. So one of these carbons is going to be in the middle, and then you realize there's two carbons, which of course means that you're going to have several central atoms, and now you're starting to realize why this is not the way we're going to operate. Having said that, let's begin. How would you go about doing this? Well, you would assume that the carbon atoms are in fact bound to each other. And so you'd say, okay, they're going to be bound to each other, and then this carbon has two oxygens, and what I'm doing here is basically a formalism that shows up in your book, and this is a way of representing structures that's in your book, and so you would need to be able to extrapolate just the way I'm doing here. Nevertheless, this is how you would go ahead and generate the overall connections as drawn, as indicated by this molecular formula, and then now you would go ahead and populate this with the rest of your electrons. So all I'm doing here is filling out the requisite number of electrons to end up with a neutral structure. So keep in mind that you just simply need to have the top row of the periodic table memorized and recognize that carbon always brings 4 electrons to a Lewis structure, oxygen always brings 6, nitrogen brings 5, hydrogen brings 1, halogens, fluorine, bromine, chlorine, iodine, they always bring 7 electrons. If you know that, then you can go ahead and generate Lewis structures for organic chemistry by inspection. You can just simply write them down, and they will almost always work out this way, where what you do is you draw 2 bonds to oxygen, and then you fill in the rest with lone pairs, and you draw 4 bonds to carbon, and so on and so forth. When you need to generate carbonyls, C double bond O, then you draw those, and so on and so forth. So this is the way you do it. Quick check of the formal charges would show you that this oxygen has 6 electrons that belong to it, 2 from the shared double bond, 2 each from the lone pairs, 6 electrons total, so that is formally neutral. Likewise, this oxygen shares 1 electron with the carbon, it shares 1 electron with the hydrogen that formally belong to it. It has 2 lone pairs as well, so that's 6 electrons that belong to that oxygen. This carbon is sharing 4 electrons total with that oxygen, but 2 belong to it. It's sharing 2 electrons with this carbon, but 1 belongs to it. We already mentioned that it's sharing an electron in this direction that belongs to it. And so this carbon has 4 electrons that belong to it, and therefore it is happy, it is neutral. Likewise, this carbon has 3 bonds to hydrogen, each of which grant it 1 electron, 1 bond to a carbon, which grants it 1 electron. This one's happy. Obviously, all the hydrogens prefer to have single electrons. This is formally neutral, and this is how you generate a Lewis structure for organic chemistry. That's it. That is the skill in a nutshell. This is in many ways easier than the kinds of Lewis structures that you're already used to, but nevertheless, this is the skill that you absolutely need to be able to have. If I give you a formula like this, you would absolutely need to be able to generate that. Now, normally what you're going to do is just work with these structures at the outset. I'm not going to ask you to do this, but you need to be able to do this. All right, so same idea by inspection. Let's do acetone. What you're going to have is a carbon in the middle, which makes a bond to the oxygen, and it has to be a double bond if you work through mentally how this all works out. And what I've already done is trim this down some, because it's really irritating to go ahead and draw things that look like that, where you draw out the hydrogen. So most organic chemists would draw it instead this way. And then again, if we're trying to figure out how many electrons belong, well, you need to fill out the lone pairs on the oxygen. It has 2 lone pairs. It's sharing 4 electrons with this carbon, but 2 belong to it. It has 6 electrons around it total. That makes it happy. This carbon is sharing 2 electrons in each direction, but 1 of those belongs to the carbon in the middle. 2 belong to the carbon in the middle from the CO double bond. Therefore, this carbon has 4 electrons and it's happy. Each of the CH bonds grants this carbon 1 electron. The CC bond grants it 1 electron. It's content. And again, absolutely foundational skill. One you definitely need to know. So to clarify, this specific skill that you need to have in Lewis structures for organic chemistry is absolutely the ability to recognize the formal charges of every atom at a glance. That is the skill you need, recognizing formal charges. If you have that, you're set. If you don't, you need to practice this skill some more.